Hello, welcome and good afternoon to everyone to the session of a Hadoop-enabled ship tracking application for the Port of Rotterdam. My name is Frank and I'm here with co-presenter Mansour. First, something different. Yesterday evening we went to look for dinner, so we ended up at the Rue de Bouchers. Who have been there recently? Can I see a show of hands? It's a very famous street for tourists to find dinner. And actually what we noticed is that it's a very prime location for all the restaurants as well. And even more so, the restaurants at the beginning of the street draw more customers as they get more customers to go with it at the beginning, so they pass by first. And if they catch the customer, get them to go into the restaurant, they wouldn't go into somewhere else. So what does this tell us? That its location is very important. And if you also notice this guy here, he's wearing the Hadoop Summit bag. So I just took this shot just candidly, and he happened to be in there. So if he's there, I'll buy him a drink. So location is important, not only for restaurant managers, but also for bigger companies and also for the Port of Rotterdam. What they are interested in is, of course, to know, for example, where are the ships? One way to find out where the ships are, of course, is by looking around. Well, then you shouldn't do as these guys, as they're looking in the wrong direction. But there's other ways to find out where are the ships. And actually each ship has a transponder on board. And this transponder just continuously broadcasts the location of the ship, the ID, the speed, and a lot of more useful information. And this information is, of course, received by the Port of Rotterdam as well as any other ships in the area. The system is called Automatic Identification System. What is this data being used for? It's used operationally at the Port of Rotterdam authorities to manage the ship safely to their berths. So that's done in a radar and control station like this one. And also, well, that's the primary task of the Port of Rotterdam authorities, to get the ships in safely, of course. Besides the AIS system, which can be turned off, it's like comparable like the system for the airplanes. You know, the MH370, which turns off its transponder. Well, it's similar. Ships can turn off the transponder, so then it may get lost somewhere. To prevent that, all around the port there's radar stations. And actually here's a radar on top of this thing, on top of this control station. So we know exactly where the ships are, even if they turn off that transponder. The operators doing this are the vessel traffic service operators. What's really the challenge of the Port of Rotterdam? One of the things is ships are getting bigger and bigger. This is one of the biggest container ships. This can contain 18,000 containers. Well, I find it hard to imagine, but how big that is. But if you imagine, there's you can ship 125 million pairs of shoes with these containers. Even that's hard to imagine. But it can ship 7 pairs of shoes for every person in the Netherlands. Now we're getting something. Actually, if I were Santa Claus, I would use this ship instead of the sled with the reindeer, because with this ship we can ship all the presents for the whole of Netherlands in one go. Well, as ships are getting bigger and bigger, it all needs to be transported back to the hinterland, to the Netherlands, to Belgium, also to Germany. And that's done by shipping, by road, and that places a stress on all the infrastructure. And the CEO of the Port of Rotterdam has said, well, actually, the port should become smarter, faster, and more sustainable. And one way to do that is actually to innovate. We can, by means of innovation in information technology, we can make it smarter, faster, and more sustainable. Actually, all the data from these ships is stored as well, and is valuable information for all the analysts in the port to see if there's any port lag. I'll show you. It's actually stored in a Hadoop platform. I'll show you application for the analyst to just retrieve this information and to visualize it. This is a map of the Port of Rotterdam. The analyst can just open a dialog box, which is the catalog, which contains all information he can drag to the map as well. And also can start tools. There's a set of tools here on the Hadoop platform. And by clicking on those tools, he can open a dialog box, and thereby selecting a date and time to select tracks in the database on the Hadoop system. What's special about this, we can also select an area. So we can just draw an area and select only data from that area. Next we click OK, and then the process is started on the Hadoop cluster, and we retrieving the data. After some time, the data shows up, and here it shows that we're having, it shows all the tracks within 1 hour. The tool also allows us to zoom in and query individual tracks as well. But already we can see here something. This area here is very congested. In Dutch it's called breed deep, which translates to broad and deep, but as you can see it's not broad, and I know by heart it's also not very deep. Well, actually these are the highlights of this presentation. We're dealing here with a geospatial data set. This is really the only one that I can see in this Hadoop Summit, so it's very special, and I really thank you that you are here today. Furthermore, we're dealing with sensor data. Well, we're not alone with that, although others deal with social data. Typically of sensor data, it's that it's very structured. It's always similar messages, but it's not flawless, like your GPS in your car. At times it's just wrong. It's not where you are. And what I've just shown you is that we have actually easy access to the Hadoop functionality, so analysts can just retrieve information with just a few clicks. In actual fact, the end user doesn't even need to know that he's using Hadoop. So actually that's my whole presentation. Anyone want to go for early break? Or do you want to know how we did this? Okay, let's go ahead and see how we did this. First, a bit of a background, introduction of the speakers. Mansour Raad is here, as I just mentioned. He's the big data advocate of Esri, which is the world's largest GIS company. And myself, Frank Kramer, I'm an independent consultant on big data and GIS. And I've been consulting for the port since 2008. Actually, I work for a small company which is called Geomatic, which is probably world's smallest GIS company in the world. Bit about Port of Rotterdam. It's the 8th largest port in the world. Actually, the first 7 are just Singapore and a lot of Chinese ports. So they're not really a competition for the Port of Rotterdam. It's the largest port in Europe by far. It ranges for a total area of more than 12,000 hectares, which is more than it's almost comparable to the Brussels region where we are in here now. What's more important for this presentation is actually the traffic. We see about 35,000 sea ships coming in every year, visiting the port. And as a consequence, there's 80,000 barges which transports the goods further on. Also, there's 7.5 million trucks every year. So there's a lot of traffic that's being generated. In this diagram here, you can see the model split between the different modalities of transport. Also, the area is very big. It's over 40 kilometers. Actually, it takes a barge 4 hours to sail from one end to the other. So it's really huge. What do we do with all this data of ship position? Well, there's actually 3 customers. First of all, there's the harbor master. In case there's an incident, they want to know where it happened and what happened, so we can look back. Also, they want to see if there's any measures for safety, if they're being adhered to retrospectively. Second customer is capacity management. They're interested in finding out, are there any bottlenecks for especially barges? And they want to have information to make a supported decision. If they're going to change that small little passage, the broad deep, if we want to widen that, is that really worth it or not? So they want to have input for their models. And lastly is environmental management. This data can also be used to make calculations, for instance, on NOx. This work originated from the Port Maps project, which actually was there to deploy a new geographical information system. This GIS system has been deployed in partnership with Esri. Actually, there's 2 key characteristics. It's to provide one uniform source of data, so we always look at the same key row, same berthing area. And the second one is easy access for all the people in the port to get this information. And as part of this project, there was also the ship position data. Well, if you look at that data, we are asking, is it big data actually? Well, this is the scorecard for this kind of data. You know, the volume, velocity, and variety. If you look at volume, it's about 5 terabytes since 2009. Doesn't look big, but it's actually 18 billion data points. Those of you who have seen the Pinterest presentation just now, they're talking about 50 billion pins. So it's not that far off in that sense. Moreover, there's the velocity. There's about 1,000 records every 10 seconds coming in. So we get it in batches in every 10 seconds. It doesn't look also so much, but during this presentation, another 250,000 records has been added to the system. Of course, it's one single data format, so that one is definitely out as in terms of variety. As I said, the challenges are, well, we're receiving data continuously, and we get like 10 million records per day. We considered a more standard option like a geospatial database, but we discovered that actually it's quite expensive, and it needs some custom work, especially in terms of partitioning, in order to make it work. And doing analysis based on that is not so easy. You may have to write it in SQL in order to run it on the database, but that's not so easy with this kind of data. Secondly, we considered Hadoop. Of course, it runs on commodity hardware. It's actually built for huge data sets, even much bigger as the ones here. And actually, it contains a framework for analysis. So that's obviously a very good choice, and that's why we went for that. How does the architecture look like? Actually, this is an overview of it. Basically, we have the radar IES, the data gathering coming in. We're using Flume that looks at a spool directory for the data, and it just places it in the Hadoop cluster. On the query side, we use the Esri platform. We have a TIC client, which is ArcGIS for desktop, which is used by the more analysts within the Port of Rotterdam, and we have a web map, which can also for other users. Both are talking to a server where a custom Java toolbox has been deployed. And actually this Java toolbox schedules jobs on the Hadoop cluster and then retrieves the information back and presents it on the map using these two applications. Next one is up, Mansoor.
So when Frank called me up to come and help them out here, we walked into the harbor and talk about commodity hardware. That was actually an experience that was amazing. I always, they always talked. I always set up a cluster on, on Amazon or some real hardware and stuff like that. At the harbor at the time, I had a very short time to deliver that application, and so I walked in and I literally looked around, and they were literally discarded R200 Dell out of warranty server sitting on the desk on the side, and I'm like, can I please use these things? And they're like, yeah, sure, take them. So literally took them out. Dust them out explicitly, take the dust out, put them in a rack, like what you see in here, put 4 of them. These are our Dell R200s. Each one of them had 2 1-terabyte hard drive, 4 cores, 16 gigabyte. Wiped out Windows from them, put CentOS on it. And at the time, I had CDH, because I had the CDH very quickly on it. And at the time, that was about over a year and a half ago. And within half a day, set up the CentOS, set up the CDH on them, and about half a day, I had the old system ready to go. It was all humming and stuff like that. Then I turned around, I went to Frank. I'm like, Frank, okay, now we're ready. We have the system up and running. It's so cool, and let's bulk load some data. So he gave me some USB drives. He gave me about 2 of them. Each one of them holds about 1 terabyte worth of data and had a bunch of CSV files, And so what I spent the weekend I flew there on Wednesday, I think, and then we bulk loaded the data. And spent the weekend, I wrote a big fat MapReduce job to bulk load all that stuff in there. And so I don't call myself a data scientist, because I'm not a data scientist, because I'm a data janitor, because that's what I do. I clean data all day long, and I basically shove it in there. And so once I wrote the MapReduce job, I bulk loaded all the data in there. And 2 days later, I was data monkey. I was taking one USB, plug it into the hard drive, and then put it into HDFS and running the job. And then it took basically about 2 days to load about 2.5 terabyte worth of data. And then once that was done, says, okay, well now we need to do analysis. So this is where I started collaborating with Frank here, and he's going to take over and tell you more about the detail about the explicit jobs that we did to do with the data. All right?
Yes. Thank you, Mansoor. But first, a little bit about the data itself. As Mansoor said, it's CSV data. This is just one row of data. Well, it takes a bit of time to make something out of it, but if you look closely, you may see a track number, a unique number which is called MMSI, which identifies the ship, X coordinate, Y coordinate, some navigational status, length, width, time. Well, let me help you a bit. Well, the track number is here. MMSI is here. Well, then we know which ship it is. Then we have X coordinate, Y coordinate, some navigational status. In this case, it's anchored. And we have length and width, which are actually in decimeters, and the time, UTC time. So that's the data. To store it, as Mansoor said, we have used the MapReduce job to store it, but yeah, we also had to think about how to store it. Of course, we get it every 10 seconds, but we're not going to store small little files into the Hadoop file system. So we like to aggregate them into larger files. Furthermore, we noticed the use case. Often the customer is interested in selecting time for a certain time range. So partitioning by date and time is logical, and that's exactly what we did. So we partitioned it all the way up to 1 hour. And we stored it in separate directories for each partition. What also noteworthy is, noteworthy is that, well, we use this structure as year is 2015, etc. And that one helps in Hive if you want to reconstruct your partition. It's just one command to find all the partitions because the keys are clear. We put this into production sometime later because, of course, the small little cluster was nice to start with, and we used it actually in pre-production as well, but we want to have something more secured. We went to our main IT service provider, which is KPN. They deliver Hadoop as a service, which is based on HTTP 2.1 at the moment, but they're upgrading to a new version, I've heard. It consists actually of 4 data nodes, and each data node has 12 cores, 96 gigabyte of memory, and 3 times 4 terabytes of disk. It's all running as virtual machines, but they've ensured that the disks are not shared, so it's really each virtual machine has their own access to their own disk. Actually, at the background, you can see the KPN data center, and this is the actual cluster where it runs on. A little bit about the configuration of Flume. We use Flume for the real-time ingestion of data. Actually, the main thing we need to do is extract the timestamp to use that for the partitioning. And we built a custom serialization to store it in HDFS, which basically selects the correct fields and does a little bit of housekeeping there. We have developed several tools. These are just a few examples of them. We're still working on more of them. First of all is the polytrack tool, is to retrieve tracks. I've just demonstrated that. We have a line tool, which determines line crossings. We have a speed tool, where we can measure speed over certain parts of the harbor. And we have a density tool as well, which can show the density of how busy certain areas are. How did we implement it? As I mentioned, we have a custom ArcGIS Java toolbox. In terms of architecture, well, we created a library which contains the core code, and then we have some code which we can run directly onto Hadoop for batch jobs, and we have some code for ArcGIS, interfacing with ArcGIS, and we have a little bit of Flume as well. Actually, we started off with a client toolbox, but we want to have it server-based, so we can have a single point for all these services as a geoprocessing service. It's almost the same, but there's certain functionality that's not available, like the extent of the map is not known in a server environment because they don't have a concept of map. One of the main things we also did is have feature sets as input, and that allows us to geographically draw inputs, as I just demonstrated earlier on. And of course, the nice things about Java is we can have all the unit tests and do testing before really deploying. This is an example of accessing the data from the browser. This is just a web browser, which you can start up. And then you can just click one of the tools. In this case, it's the line tool. You have a similar dialog box, so we can select start date, end date, and some attributes if we are interested in certain ships. And then we can just run it. We can also select a line, in this case, where we want to see what are the line crossings there. And we can run it, and we can see all the line crossings. Of course, we can zoom in, and we can also want to know more about one of them, we just click on that, and it gives us more information. Actually, this tool may seem very easy to use and not so difficult, but what's actually abstracted from the user is some properties of the data. As I said early on, AIS, like GPS, is not always so reliable. If we look at just 1 hour of data in a certain area, and we draw a line for which we want to count, then we see all these tracks here, and it's not so trivial to get a consistent count. For instance, the purple track seems to be crossing 3 times, but the end users actually won't only consider one time. So there's a lot of, yeah, well, as I said, actually the devil is really in the details for this implementation, and that's really abstracted from the user. We also run this tool as a batch job on 55 lines throughout the harbor for a full year of data. Here are some results of over the 12 months, aggregated to 12 months. Actually, on this cluster, it now takes 1 hour to run, which is still quite long, we find, but it's a lot better than before. We had even a Hadoop cluster. Then it took us about a week to run this analysis on a PC. But at this time, we have actually 6 times more data than we had back then. So if we want to do it the same, it's now 1 hour versus 6 weeks. So that's really a huge improvement. Another tool we created is the density tool. Basically, you can lay over a grid over the map and then determine how many ships are in that grid over a certain period of time. And the output are actually the grid points and a population number. Well, I did it here with all the grid points. It's almost hard to see. It's almost faded out, so many grid points there are. But the nice thing with GIS is you can use very nice visualization, and you can put a color map over it. And what you get then is something like this. Here you can clearly see individual shipping lanes. And also you can see again a hotspot here where there's a very narrow passage. What are the challenges during implementation that we came across? Well, one thing was performance. We actually, from the small little cluster, we were running MapReduce version 1, and we're now using Yarn, of course, with HTTP 2.1. One thing we noticed is actually the number of containers that are scheduled per node. Initially, it was based on the memory, and a lot of processes, more than 100, were scheduled on one node. But now we restricted that to the number of cores. That improved a bit. Another improvement is actually to have more reduced jobs for bigger jobs. In MapReduce version 1, there's just a fixed amount of allocated reduced jobs already. In Yarn, you have to specify that. That's what we run into. Another major thing is actually connectivity. Specifically, we run into that when the application master is started up, it communicates back to whoever started that master, but it doesn't properly go to the firewall. You need to have firewall rules. We prevented that issue by just submitting the job and getting back an ID and actively polling the resource manager. Also with Flume, we noticed some issues. Sometimes there's a backlog if Flume has been stopped for some time. And then there can be too many files in the spooling directory. And we notice Flume gets really slow, especially on Windows file share. Even so slow that it takes more than 10 seconds to process one file, and then it's never going to catch up because it's getting files every 10 seconds. What we did is actually spoon feed Flume, so we have a separate spool directory where we limit the amount of files there. There's one spool directory where all the files are there, and they're just taken there and put in a second directory, and if it's more than 100, for example, then it doesn't put more into it, and therefore Flume remains really fast. Actually, we could process up to 10 files per second, so about 100 times faster than real time for Flume. So that's really no issue. Some ideas for future work. As I just learned this morning is that, if you want to be a good Hadoop specialist or big data specialist, you need to do it from end to end. I think I've shown that so far. And then you need to see how can we do it better. And these are some ideas for that. Well, one thing we really want to look at is at Spark. Well, we think could dramatically increase our processing time and should also make development a lot easier. On the ArcGIS side, we are thinking about using Python, which is actually a bit better supported and documented, and also easier for development. And yeah, to make things easier for firewall rules, because actually the cluster is running at a different location, physical different location than the Port of Rotterdam, so there's a lot of firewall rules that needs to be bridged. We are thinking of having a web service at the cluster, which is the single point of entry, and that makes it a lot easier for connectivity. And we're thinking about using Spring for that. Well, the technical conclusions are actually, yeah, we have really placed the geospatial application of Hadoop into production. It's really integrated into the existing GIS system, and it's really easy to use for end users. What are the benefits for the Port of Rotterdam? Here are some testimonials. Basically, it comes down to that they can have faster access to their information, and therefore they can run queries more often. What they're also saying is, yeah, can use it with existing tools. So therefore, our Hadoop solution is providing more insight in the usage of the port in terms of shipping, and it provides results more often. So it's smarter, faster. And what I've not shown yet, but what we can do is do pollution calculation, so we can make it more sustainable as well. And that links back to the CEO of the Port of Rotterdam, Allard Kastelein, his message at the beginning. Some questions. I have two for you. Maybe for your application, you can also think, well, how geospatial is actually your data set? Because, well, location is everything, but so location in your application could be also very interesting to do a lot more with it, like I've demonstrated here. And the second thing is perhaps you can use a similar approach as we have chosen here. There's a question there.
Hi, I'm wondering if you're using this data also to make predictions where bottlenecks are coming up in the harbor based on data coming in.
We're not using that currently. What we're doing is actually getting statistics out from this data set, and that's fed into models which really predict this kind of future bottlenecks. So we're doing it at the second level, but this data is definitely needed to make those predictions, and it might be good also to look at it in a more integrated way.
So we have geospatial tools to do that, and that does it in statistically correct way. So like hotspot analysis, what actually Frank was showing here was a heat map, was just a cell with a bunch of numbers on it. And that is different for us than a hotspot, which is actually a point and location with associated with it is a probability of how much of a heat it is or how cold it is. And then one of the other things that we do is we do emerging hotspot analysis, which is what you're looking for, is basically seeing over time how that hotspot is actually trending, and is it trending statistically correct or not, and then turning it into what we call a geo-regression to then do the prediction. So what you're seeing here is just the tip of the iceberg, and what Frank did not show is the other stuff that the emerging hotspot, the hotspot analysis, the statistics behind it, to actually give the executive decision makers not just pretty pictures, but actually numbers that they can actually go around and say, you know, I'm confident at the 90, 95, 99% probability of this, and that's why I'm making my executive decision that way. So these are what we excel at very well, and bringing geospatial to it makes it really very different.
Hello. Well, this is very interesting and very inspiring work. I have two questions. First, how complicated it was to connect your ArcGIS server with your Hadoop cluster?
Yeah.
And the second question is, can you run like really heavy geostatistic jobs like a Bayesian kriging or something with the same cluster, or do you need to set up a separate one? Thank you.
Yeah, very good question, actually. So the integration between ArcGIS and Hadoop is actually very straightforward because of ArcGIS is fairly extensible. So we can extend it with .NET, with Java, or with Python. Because the assembly language of Hadoop is Java, when Frank and I worked on it, we extended the ArcGIS server with the Java toolkit, and we were able to use the Hadoop libraries and with our MapReduce libraries, and we were able to execute it on that. So that was fairly straightforward. As far as your question, which is the next thing, to do the kriging and to do some of these more complicated stuff, actually, these are the stuff that I'm working on right now, me personally. And I'm turning to, like, for example, the first one I talked about is the hotspot analysis. Now, something very important. We've been so used to writing our algorithms in a traditional serial, one machine that have access to all the memory and all that stuff. And one of the reasons why we have to stop a little bit, and when we start thinking in distributed parallel share nothing environment, kind of like MapReduce, is how to take those existing algorithms and turning them into distributed share nothing platform. And these are where some of the krigings and some of the stuff are a little bit more difficult to do. And that's part of my job right now, is actually we're going to be releasing that summer. Some of these, we've taken some of these geoprocessing, and we've rewritten them from scratch in a totally distributed parallel way. Actually, Frank was talking about using Spark. Actually, personally, I haven't written a MapReduce job, a Hadoop, let me rephrase this. I haven't written a Hadoop MapReduce job in over a year, I'll tell you honestly. I've been doing Spark since actually when we left that project. I wish, hindsight is 2020. That's why I've been beating up on Frank here. Frank, you got to do Spark, buddy. Come on, get with the 21st century. You cannot stay in this MapReduce because you're killing yourself. And it's making my implementation of the krigings and all these complex stuff a little bit easier. Now, am I going to be able to do everything? Not yet. I'm taking right now only the 20% tools that people are using, and then I'm going to start bringing in the other stuff. But what I have to do is I have to go back to the math and really understand what the math is explicitly trying to say and do it. And that's a reason for you guys when, like, I fight with my child all the day. I have a 13-year-old that tells me every day that he hates math and geometry sucks, and why do I lose it in the rest of my life? And I tell him, son, why you have Nike shoes that's costing me $1 million on your feet is because I love math and I do math every day. So moral of the lesson, stay in school and learn your math. Tell your children that, because that's what's paying for them to have all the fancy stuff, all their iPhones and their Instagram account and all these wonderful things. Okay, so stay in school, kids. Okay?
Okay, there's a question here. The microwave is on. The microphone is on the way. Yeah.
Hello, my name is Amer, and I work for Stena Line, which also is a company that works with freight ships and ports and stuff like that. How did you convince the organization to go for this approach? Usually it's old mentality, we've done things our way.
Well, the good thing is actually we here piggybacked on the Port Maps project where they really revamped the geographical information system. So that really helped, and well, we just needed to find a solution. So I think we were just there at the right moment and the right time. And actually one of the things which really helped, and was also Mansour explained, is in a short period of time with just a very small cluster, he could demonstrate the benefits of this way of working. And that convinced really the Port of Rotterdam to go ahead with this solution.
So the SLA that we had to meet, so this project kept going for about a year. So about December came in. Somebody realized that, holy cow, it's December, and by January I have to meet an SLA that I have to hold all this data 5 years online. And they started freaking out, okay? Because why? The traditional means, the relational database guys, what they're gonna do, they said, no problem, no problem. Give us your data, we'll hold your extra 6 terabyte of data. Oh, by the way, you have to buy those extra 100-node cluster. And oh, by the way, on that 100-node cluster, it's gonna come all these cha-ching, cha-ching, cha-ching. And that's where things started to freak out. Thus, the call to Mansour. Okay? So Mansour, come over, get your butt down to the Netherlands. So I showed up, and this is exactly what we did literally in 3 weeks. We literally stood up all that work. We did that in 3 weeks, by the way. And all that because of, I was telling you, the commodity hardware. I was able to start up, literally walked into the office, and I'm like, I'll take those guys, give them to me. CentOS up and running, work with Frank very quickly on that. And because of that time, time and space, no pun intended, was perfect. We were able to do that all in 1 week and basically meet the criteria and within the budget that was left in that 1 month. And once the port saw that, we were pushing, I call these system, like what Frank was showing, PhD system, push here dummy, because I don't know the port very well at the time, I used to call them push here dear instead of push here dummy, PhD system. Once they push a button and it was doing the thing for them, they're like, okay, we believe, amen, praise the Lord.
Okay, last question, then it's time for a break, I think.
One question about the fields that you're actually storing. If I understood correctly, you're only picking certain fields from the file that you're getting in, and the rest.
Yeah, actually we get about there's about more than 100 fields in total that we're getting in, and we're picking about half of them. We could have stored everything as well, but some of them are really redundant, so that's why we choose not to store them.
Okay, but I thought you were only storing the 7 or 8 that you...
No, those are just an example, indeed.
Yeah.
And if we had to do this again, again, hindsight is 2020, we still kept it in a partition file, using time space because of schema on read, of the Hive and all that stuff, and we can partition. Again, hindsight, we've done this over a year and a half ago. Hindsight is 2020. I would have picked up a Parquet file format, so like that, because if tomorrow Frank wanted to add these extra 90 fields, well, what is he going to do with the 6 terabyte that he already has? And so now he has to go deal with that problem. If I had the Parquet file format or, schema with the database, then tomorrow, boys and girls, more things are coming in. Parquet does not care, or whatever, schema file and read, and then that's it. He grows, and if he shrinks up and down, all the processing will still remain the same. So these are part of the lesson learned, and again, hindsight is 2020, and well, hopefully we'll do this again, and we'll do the Spark, we'll do the Parquet, we'll do all these wonderful extra things that coming in, and then we'll do better.
Indeed, we have done it once, and now we know how to do it better. That's progress, I think.
Thank you. Very interesting presentation.
Okay. Thank you very much, everybody. If there's more questions, we will be available around here. And I think it's now time for a break.
Thank you, everybody.